There are two versions of the CRP-5, the CRP-5 and the CRP-5 wind arm. For the CRP-5 you'll need a pencil and a good eraser of the type shown. We will follow the examples in the CRP-5 handbook, so keep that to hand also. The drift variation fixed scale extends by 50 degrees either side of the true heading index mark. The scale can be used for either applying variation to convert between degrees true and degrees magnetic, or for applying a drift from heading to track. The right hand side indicates starboard drift, the left hand side indicates port drift, and in the centre is indicated true heading. Always remember that you are blown from heading to track. For example, heading is 075 degrees true, drift is 11 degrees port. What is track? The true heading is 075, so line up the inner scale value of 075 underneath the true heading index. Look for 11 degrees port drift on the left hand side of the outer scale, which is here. True track may be read underneath, which is 064. Let's try a slightly different example. This time heading is 227 degrees true and track is 241 degrees true. What is drift? Set up heading 227 degrees true underneath the true heading index. "241" is over here, which is your track. You are blown from heading to track. Drift is 14 degrees starboard. Application of variation is best achieved using the mnemonic "Cadbury's Dairy Milk is very tasty" or "Can Dead Men Vote Twice", which stands for CDMVT. Compass, deviation, magnetic, variation, true. Then draw an arrow going to the left and write down "add it if west". For example, if heading is 217 degrees true and variation is 21 degrees east, what is heading magnetic? East is the opposite of west, so instead of adding for west when you move left across CDMVT, subtract for east. 217 minus 21 equals 196 degrees magnetic. Another example. Heading is 005 degrees magnetic, variation is 8 degrees west. What heading is degrees true? Variation is west. You would add if you were going left across CDMVT, but you are going right, the opposite. Therefore, subtracting 8 from 005 equals 357 degrees true. The slide has two sides. This side depicts the low speed side, marked L at the top right. The low speed arcs marked on it range from 300 to 40. Drift lines radiate outwards vertically. Here is the 10-degree drift line. The bottom section is typically used for calculating headwind and crosswind components for runways. The slide has a graduated scale. On this side it may be used for marking measurements in nautical miles on a 1 in 500,000 chart. The other side of the slide is known as the high speed side, recognised by an H marked at the top right. The high speed arcs marked on it range from 1000 to 150. Drift lines radiate outwards vertically. Here is the 5-degree drift line. Note that the values for speed are presented above the line to which they refer. There is a smaller bottom section for calculating headwind and crosswind components for runways. The scale on this side is for making measurements in nautical miles on a 1 in 250,000 chart. The triangle of velocities concerns heading and TAS, wind direction and speed, and track and ground speed. Let's set on a wind velocity of 210 30 knots using the low speed side. Rotate the inner scale so that 210 appears under the true heading index. Position, say, the 130 speed arc underneath the centre dot and count down 30 knots below the centre dot to where the 100 speed arc crosses the centre line and draw across. This shows wind from 210 at 30 knots, drawn down. Let's try an example. Your heading is 116 degrees true, TAS 120 knots, wind velocity 260 40 knots. What is the track true and ground speed? First of all, decide which side to use. Since TAS is 120 knots, use the low speed side. Rotate the inner scale so that 260 appears under the true heading index. Then draw on the wind down. Position TAS of 120 underneath the centre dot. With the wind drawn on, now rotate the inner scale so that the given heading of 116 appears under the true heading index. Under the wind cross, read off 9 degrees port drift and ground speed of 154 knots. Heading is 116. You are blown from heading to track. With 9 degrees of port drift, you are blown 9 degrees port to a track of 107. Let's try another example. Heading is 227 degrees true, TAS 420 knots, track 234 degrees true. Ground speed is 385 knots. What is the wind velocity? First of all, decide which wind side to use. Since TAS is 420 knots, use the high speed wind side. Move the slide to position 420 knots TAS underneath the centre dot. Now put the heading on by rotating the inner scale until 227 is under the true heading index. Track is 234, which is 7 degrees starboard. Draw a line over the 7-degree starboard drift line. Find the given ground speed of 385 knots and draw a line along the 385 speed arc through the 7-degree starboard drift line. Rotate the inner scale until the cross is over the centre line below the centre dot. You may now read the wind direction of 177 degrees true under the true heading index. The wind speed in this case is not easy to count out. To make it easier, move the slide to say 400 knots. This does not affect the reading. 10, 20, 30, 40, 50, 60 knots. (177), 60 knots. Another example. TAS 170 knots, wind velocity 083.35, required track 036 degrees true. What is heading true and ground speed? This is the practical example that you use in everyday flight. TAS is 170 knots, so use the low speed side. Move the slide so that 170 knots appears underneath the central dot. Draw the wind on first by rotating the inner scale so that 083 appears under the true heading index. Count down 35 knots from the central dot. 10, 20, 30, 40, 35, and draw across. Rotate the inner scale to a required track of 036. Drift is 10 degrees port. Now we need to drift balance. Rotate the required track of 036 to 10 degrees port. Check where the wind cross is. It shows 9 degrees port. Rotate the required track of 036 to 9 degrees port. Check the wind cross again. Both readings of drift are the same, 9 degrees in this case, so drift balancing is complete. We can now read our heading of 045 under the true heading index, and a ground speed under the wind cross of 140, 142, 144 knots. Let's check the wind velocity at a turning point using an example. TAS is 220 knots, inbound heading is 195 degrees true, with drift of 6 degrees, starboard. Outbound heading is 278 degrees true, with drift of 4 degrees port. What is the wind velocity? Using the low speed side with 220 knots TAS underneath the central dot, rotate the inner scale so that the inbound heading of 195 appears under the true heading index. Now draw down the 6 degree starboard drift line. Then rotate the inner scale so that the outbound heading of 278 appears under the true heading index. Draw down the 4 degree port drift line. Now rotate the inner scale so that the cross which has been formed is positioned on the centre line below the centre dot. Counting down 10, 20, 30, approximately 32 knots, and wind direction 066 degrees true. Headwind and crosswind components on a runway are solved on the squared section at the bottom of the slide. For example, calculate headwind and crosswind components on runway 19 with a surface wind of 150, 25 knots. First of all, move the slide to position the top line of the squared section through the centre dot. Put the wind on first, which is 150 degrees magnetic, lined up under the true heading index. And count down 25 knots. Move the inner scale so that the runway direction of 190 degrees magnetic is positioned under the true heading index. The cross has now moved out to the right. We have a headwind component counting down of 20 knots and a crosswind component from left to right of about 17 knots. Headwind and crosswind components may be calculated using an electronic calculator using the following formulae. Crosswind component equals sine of the wind angle multiplied by wind speed. The wind angle is 190 minus 150 equaling 40. Sine of 40 multiplied by 25 is 16 knots. Headwind component equals cosine of the wind angle multiplied by wind speed. Cosine of 40 multiplied by 25 is 19 knots.